This video is presented to you by www.testprepadda.com.
Dear students, this is exercise number 11 of General Organic Chemistry. The questions of this exercise are based upon lesson number 38 and 39. So, you must watch those video sessions of General Organic Chemistry before attempting the questions of this exercise. Let me tell you, this exercise has 5 questions. First, I will show you all 5 questions. Then I will explain first and second question. Remaining 3 questions you have to attempt on your own. And you can share your answer and solution with me at teacher@testprepadda.com. Now you can see this is question number 1. This is question number 2. This is question number 3. This is question number 4. This is question number 5. Now I will talk about question number 1. Here the question says, what is the correct order of stability of following carbocations? Dear students, let me tell you, to decide the stability of different carbocations, first you check whether because of positive charge the carbocation becomes aromatic or not. So it's very important to check aromaticity. First of all, you have to check aromaticity. And if you look at these different carbocations here, you'll find this as the aromatic tropolyamine. Why? Because here you can see 2 2 2 and positive, so loop of 6 pi electrons. This obeys Huckel's rule, as well as this ring is planar ring, and 6 pi electrons means 4n plus 2 pi electrons. That is why this is aromatic, and this plus is responsible for the aromaticity of this compound. That is why this will be considered as the most stable among these compounds. So this will be number 1. Then you check that plus is attached with any heteroatom having unshared pair of electrons. For example, oxygen, nitrogen. Here you can see this carbocation is attached with oxygen having unshared pair of electrons, as well as here this carbocation is also attached with atom having unshared pair of electrons. So first this will be number 1, and then these two. Now out of these two, which one will be the more stable? For that you have to write the resonating structure here. CH3 CH double bond O plus CS3, because it is direct delocalization of positive charge. Here also direct delocalization, and you can write CH3 CH double bond NH plus CS3. So here what is happening? This empty orbital and this filled orbital delocalization, that is why positive charge density decreases. Now what is happening? Here oxygen gains positive charge, here nitrogen gains positive charge. Let me tell you, more electronegative element is less capable of holding positive charge. That is why out of these two, this one will be the more stable. So I will write this as number 2. I will write this as number 3. My point is clear. And students, don't get confused here. This positive charge is not responsible for the aromaticity of this benzene ring. Okay, that is why this will not be considered the stable case as we did here in aromaticity. Now look at this. This is a very special case. This is cyclopropyl methyl carbocation. So what is happening here? What is the bond angle here? 60 degree, 60 degree, 60 degree, equilateral triangle. But if I ask you what is the hybridization of this carbon, it is sp3. So what should be the bond angle as per sp3 hybridization? 109 degree 28 minutes. But the bond angle is 60 degree. That is why you can say what? Highly strained. Highly strained. Because of this, the orbitals become bent orbitals. Normal sigma bond formation takes place how? By the axial overlapping of the orbitals. By the axial overlapping of the orbitals. While in this case, what is happening? The orbitals become bent like this. Orbitals become bent. Now, bent orbitals are there. And here you have p orbital, empty p orbital. And let me tell you, this empty p orbital is parallel to bent orbitals, not perpendicular. So, this results in the conjugation between bent orbitals of cyclopropyl ring and vacant orbital of carbocation. So due to this delocalization, stability increases, and this is direct delocalization. That is why it is more stable than the benzyl carbocation. It will be more stable than benzyl carbocation. So I will write this as number 4 and this as number 5. So the correct answer will be this 3 greater than 5, 3 greater than 5, greater than 2, 3 greater than 5, greater than 2, greater than 1. And then last will be this fourth one. That is why for this particular question, the correct answer is option C. Okay, now I will talk about question number 2. Here question says, following compounds are reacted with AgNO3 solution. What is the correct order for ease with which they react with AgNO3? Now AgNO3 when reacts with these compounds, actually there is a possibility for the formation of AgCl. So this compound or this compound or this compound, these compounds should ionize and should produce Cl minus, so that Cl minus can combine with Ag plus to form AgCl, and that will depend upon the stability of carbocation that we get after ionization. For example, in the first case, what carbocation will we get here? This. In the second case, we are going to get this. In the third case, we are going to get this. Now, out of these three, if you look at this first one, this carbon is sp2 hybridized, this carbon is sp2 hybridized, sp2, sp2, sp2. All carbon atoms are sp2 hybridized, so ring is planar. Ring is planar, and how many pi electrons are involved in the delocalization? Resonance is there, plus single double. Resonance is there. How many electrons are involved? Total 4 pi electrons are involved in the delocalization process. That is why this carbocation is actually anti-aromatic, and when you say anti-aromatic, it provides instability. That is why it is difficult for this to ionize. So here it will be most difficult. Now out of these two, when we compare, here plus single double, normal delocalization. In this case, what is happening? This plus in conjugation with double bond, and if you look at this ring, this actually 2 pi electron case means what is happening? Aromaticity, and that is why this will be the number 1. So 3 greater than 2 greater than 1, 3 to 1. That is why correct answer for this particular question is option number 2. My point is clear. Now, dear students, you attempt remaining questions of this exercise on your own, and you can share your answer with me at teacher@testprepadda.com. Thank you.
This video is presented to you by www.testprepadda.com. TestPrepAdda.com provides free audio-visual lectures of different subjects by expert faculties, free online tests prepared by expert faculties to students who are preparing for engineering or medical entrance exams or planning to take exams like KVPY, Olympiad, etc. It provides a platform where students can interact with mentors to improve their performance in the exams. The mission of this online medium is to help students to achieve their goals. Log on to www.testprepadda.com to watch free video lectures on different topics, to download free revision notes, to take free chapter-wise online tests, progressive test, and mock test, to discuss doubts with mentors. Thank you for watching the video. To stay up to date with the latest videos, subscribe to our YouTube channel. Like us on our Facebook page, Test Prep Adda. All the best.